In this question, we want to identify which orbital corresponds to the provided quantum numbers, or if it's a non-valid set of quantum numbers. So there are 3 quantum numbers in this case. So there's the 4th, the spin quantum number, which is not shown. So in this example, we have n equals 2, which is the principal quantum number, the orbital, and then the suborbital. So we have 2, 1, -1. So allowed values of L are n minus 1, from 0 to n minus 1. So n minus 1 is 1. In this case, this is allowed. M sub L is L all the way to -L. So this is also allowed. Now, if n equals 1, the allowed values for L are actually just 0, and n sub L would also be 0. So this is a valid set, and this corresponds to the 1s orbital. So the principal quantum numbers tells you which row it corresponds to. The L's are clearly defined. So L equals 0 is the s orbital. L equals 1 is a p orbital. L equals 2 is a d orbital. L equals 3 is an f orbital. To date, in this year, we have only discovered elements through the f orbitals. Likely, when elements have electrons in L equals 4, that will correspond to a forthcoming orbital likely to be named G, I think. Now, let's go back to our question. For n equals 3, L is a negative value. So the allowed values are from 0 to L. So even though in this case M sub L would be allowed for this, this is non-valid. Okay, so in the next value, we have n equals 3, L equals 2, which is one of the allowed values, so this is correct. For the -2, this corresponds to one of the d orbitals, and so it turns out, because you can go from -L to +L, this is a valid answer. So this is a 3d orbital. If you were asked to assign a class or a direction, it would be any one of the 5 orbitals for d orbitals. For our next one, we have n equals 2, L equals 0, which is an allowed value, but M sub L equal to -1. M sub L depends on L, and L can only be, so M sub L is -L to +L. So in this case, our value can't be anything greater than 0 or less than 0, so this is also non-valid. Next, n equals 0. It turns out that n starts with 1 and goes all the way up, so this is also non-valid. For n equals 4, L equals 2, this is allowed, so we could have had L up to 3. M sub L equals 1, which is within the allowed -2 to 2 values. So in this case, we are in the 4d orbitals. Okay, what about our next one? So we have 5, n equals 5, L equals 3, which is an allowed value. M sub L is 0, which is an allowed value between 3 and -3. And this corresponds to the 5f orbital. So the trick, or not really a trick, with quantum numbers is that they all depend on one another. So the principal quantum number can be 0 or from 1 to infinity. L depends on what the n value is, so it can be 0 all the way up to n minus 1. And M sub L is L, -L to +L.